Ladies and gentlemen, $3.9 trillion. Sounds familiar? That is India's GDP today. Here's another number you may not be familiar with. $1.7 trillion. Yes, that's the number artificial intelligence alone is projected to add to India's GDP by the year 2035, as per a Niti Aayog report. To put that into perspective, that's 6 times the contribution the entire tech sector makes to the GDP today. But before we proceed any further, my dogs are hungry. So hungry they could eat an elephant. So let's address the elephant in the room, and a dirty one at that. AI is here to take our jobs. No doubts whatsoever. There, I said it. So that's not even a question anymore. The question that you ought to ask yourself is, how can I take this opportunity to propel my career in a trajectory only a few will have in the next 10 years? And the answer is very simple. The answer is to learn AI and learn AI today. But if you're anything like me, you'd say, meh, AI is just impossible to catch up with. And the jargons, they just don't seem to get any easier, do they? I mean, what does it mean when they say pre-trained or RLHF, HITL, RAG? And I would agree with you. And that's why I've made this video exclusively for you, where I've used the best tool I have in my repertoire to explain generative AI, or large language models, or LLMs as we will refer to it for the rest of this video, and all the jargons associated with it. You see, a lot of people I grew up with, my friends and my colleagues, have often told me what a great storyteller I am. So today, my dear viewers, I will tell you a story. I will tell you a story that has the potential to change the course of your life, should you choose to pay heed to it and take action. I will tell you a story of how I became the storyteller that I am today. And this is not just another story. Through this story, I will help you unravel everything about generative AI or LLMs and how it works in a way that it has never been unraveled to you before. So, here we go. Cut to the early 90s. Picture a 10-year-old me in the small, quaint town of Bokaro Steel City, my little hamlet. Like all of you, I loved the city I grew up in, and I have 1,000 things that I loved about it. But the winters were just special. I mean, I love winters, so much so that if you were to tell me that it's winters in the hell, I am coming with you. Every evening, as the mercury dropped and a thick blanket of fog grappled the streets, under the flickering yellow lamp of the streetlights, clad with sweaters sewn by our grandmothers and mothers, men, women, boys and girls of all ages, and dogs gathered around the firewood. I remember the way the darkness pressed against my glasses, and the street turned golden as the streetlights braved the fog and cut through it, leaving the dancing dust in the air for everyone to see. All of this happening as the sun goes down. Ladies and gentlemen, as the sun went down, the evenings just started to smell different. It is only now that I realize that it was the smell of nostalgia that I would have when I would remember these moments in future, like I am now. This, my dear viewers, was the perfect setting for what went on to become a marathon of stories of all kinds. By the way, if you're with me so far, please do subscribe to the channel and join me in this shared learning experience. Who knows, this might just be the trigger you needed to become the next voice in AI. Imagine the kind of stories you could be building if you start learning AI today. But going back to the story, you see, every winter in Bokaro was the winter of stories. And my neighborhood, every person was a stickler for storytelling. After we had packed our stomachs with a yummy dinner at home, like clockwork, we'd all disembark our homes to enjoy yet another night of stories. As we'd settle down under the streetlight, my father, with his booming voice, would recount the tales of the 71 war. My mother would almost sing folklores of the Baga tribe from Chhattisgarh. The Bagas believed that earth was created on just a leaf floating over water. Because water, that's all there was at the beginning of time, she would say. Almost as she had seen it all with her own eyes. My brother, as you can imagine, would whisper stories of the ghosts from the mango orchard right behind where we lived, which to say the least will send chills down my spine. The neighborhood uncle who ran his kirana store, we will call him Ramji, was a philosophical soul. He would go on endlessly about how we were all merely a drop of energy passing by Earth in a much grander scheme of things that no one really fathoms to understand. You see, everyone had a story to tell. Stories about the emergency in 75, about how Amitabh Bachchan almost died after being injured on the sets of Coolie and then miraculously came back to life. Stories about life in general, stories from the Panch Tantra, and of course, stories about cricket. I did not know it then, but those winter nights were my pre training for the storyteller that I would become later in life. In those cold yet full of warmth nights, that rich, chaotic, and endless stream of stories was my training data, a library of everything that I happily and unapologetically soaked in. Now, I know what you're thinking. This is great, but how does this actually help me understand LLMs? You see, what I just described, the pre training and the training data, that's not just a metaphor. That's literally what LLMs go through as well. If you consider the pre-training for Llama 270B, which is an LLM from Meta, you will notice how the internet data is chunked into terabytes of text and then processed using a cluster of specialized computers known as GPUs, intended for heavy computation. Now you take a few thousand GPUs, let them do their stuff for a couple of weeks, spend a few $1,000,000, which by the way is a fairly smaller number compared to what's being spent on the pre-training of other LLMs such as ChatGPT or Bard or Claude. What you get as a result is a 140 GB file of parameters, a highly compressed representation of the patterns learned from the text data from the internet and books and other sources. Now you know where ChatGPT gets all its answers from, don't you? And here's the crazy part. If you stick with me for some more time, I'm going to show you how these stories can also help you understand concepts such as tokenization, transformer architecture, RLHF, hallucinations, RAG, prompt engineering, backpropagation, etc., etc. So, let's go back to the stories. At first, these stories were just a jumble of words for me. But as a kid, you learn to listen. You start breaking things down into smaller sounds and pieces. I realize now I was performing my own kind of tokenization, tokenizing each sound or word or parts of the word. And each piece, each token, wasn't just a word. To me, it was a feeling. Sad, felt heavy, like a smooth, dark stone in my mind, whereas joy felt like a bright, sparkling light at the end of the rainbows. I was creating my own vector embeddings, a secret map of meaning where similar words were neighbors and not so similar words stayed away from each other, just like us human beings. I also learned that the order of words mattered. The brave soldier saved the boy was a universe away from the boy saved the soldier. I was unconsciously adding positional encoding to my understanding. And that's what LLMs do, both during training and during the generation of text when prompted, that is, in the inference mode. Words are broken down into smaller tokens. These tokens are then embedded into a list called a vector. Imagine a vector as something that stores the overall meaning profile of a word or a token in the form of numbers. And then imagine a second vector or list or a numerical tag which gets added to every word's meaning profile and tells the model where in the sentence the word is, basically allowing LLMs to understand grammar and sentence structure. My mind became this vast interconnected web of stories. Looking back, I can see it as a neural network. Each memory was a clearing in the woods, and crisscrossing between these clearings was a labyrinth of countless pathways. Some were wide, well-trodden roads. For example, the connection between mother and love was a superhighway, no bumpy rides at all. Others were faint, overgrown trails, like the one between Ghost and War. The condition of each path, how easy it was to travel, represented its strength. These were my weights and parameters, a very important concept in understanding how LLMs work. It wasn't just a map, it was a living landscape of relationships between words. Every single one of the billions of pathways had its own specific strength, a number representing how strongly two ideas were linked in my mind. This landscape of numbers, this entire forest of connections, was the sum of my knowledge. In other words, the sum of my being. It was truly me. In technical words, weights and parameters are nothing but numerical values which are constantly updated using mathematical operations during the training stage of an LLM. Using matrix multiplication, which is a mathematical concept where you take rows from one grid of numbers and combine them with the columns from another grid, producing a new grid that represents transformed information. So using matrix multiplication at each stage, the weights and parameters help the LLMs to 1. Map the tokens into vector embeddings, that is, break the words down into tokens and add them to make a list. 2. Transform the input vector embeddings into a more context-aware, transformed representation of the words through positional encoding. And 3. Translate the transformed vector into the next word or token prediction. And this happens iteratively. Imagine this as a layer of mathematical operations building on top of each other. As you can imagine by now, the entire intelligence of an LLM is based on these multiplications and additions, which are all defined by the weights and parameters, which are nothing but the numbers that the LLM learns during training, and weights are the most numerous of these numbers. But my mind wasn't just one single forest. It had different sections for different tasks. One part of my mind was a visual pattern finder. When I looked at the intricate patterns on the famous mosaic floor from the 90s, every home in the neighborhood had these. I was listening to a story. I was seeing a story unfold before my eyes. I'd first noticed the tiny black dots, then how they'd look like a pattern of nothingness. But then they just start to make sense. Something similar to what we've all done unknowingly when we see a familiar shape of a dog or a dolphin in the clouds. This part of my mind worked like a convolutional neural network, also known as CNN, brilliant at finding shapes and objects in space by building up from simple patterns to complex ones. While my storytelling brain cared about sequence, what comes next, this part cared about space, that is, what's next to what. A CNN uses the same mathematical operations as an LLM to transform the input data into a meaningful representation. Only in this case, the input is a pixel or pixels in the form of a grid of numbers, unlike the LLMs where the input is a sequence or list of numbers. CNN typically uses small movable windows called filters that are trained to look for specific patterns such as edges, a horizontal line, or a color gradient. The filter then moves through the image pixel by pixel, performing multiplications and additions to see how strongly a specific pattern is present in the image. This is called scan or convolution, hence the name. Finally, the result of this scan, called a feature map, is produced, which is a new smaller image. This process is repeated through multiple layers, starting with the filter looking for simple patterns such as edges, and then moving to deeper layers to combine the simple patterns to form complex patterns. For example, combining edges to find a fountain pen or a football or a hoverboard. This step is referred to as layering. And then comes the final decision, where the final layer takes all these identified complex patterns and uses them to make a classification such as this image contains a football or this image contains a fountain pen. To put things into perspective, think of CNN as a detective who meticulously scans a crime scene, the image, with a magnifying glass, the filter, looking for small clues. It doesn't care where the clue is, it just cares that the clue is somewhere there. But the part of my mind that lived for those winter nights was different. It was a story weaver, a large language model. It did not care about spatial patterns on the mosaic floor, as much as it cared about the sequence of words and the flow of time. It had a special design, and this is where it gets interesting. Instead of processing a story word by word, forgetting the beginning of the story or a particular sentence by the time I reached the end, my mind built a new kind of listening room. In this room, I could see the entire sentence laid out at once, all the words present at the same time. This unique design, this special structure that allowed me to weigh every word against every other word simultaneously, I now know was my own version of the transformer architecture. The transformer architecture, in technical terms, takes the words or sentences and converts it into a list of tokens, including its meaning and position. But the key innovation of this architecture is the self-attention mechanism, which allows every word in the sentence to simultaneously look at every other word to understand how relevant every other word is to its own meaning. The architecture operates in layers by creating multiple blocks, also known as transformer blocks. Each of these blocks contain their own self-attention, feed-forward network, and layer normalization steps that help stabilize the learning process. This special architecture is what allowed me to truly focus. When a character named Bakilal or Phantom was mentioned, I could instantly scan back through the entire sentence, connecting its past actions to its present ones. This was my attention mechanism. It was a form of self attention where every word could look at every other word to understand its true meaning. But then came the limitation. You see, I was only 10, and I could only hold so much of the story in my head at once. That was my context window. The context window is the maximum number of tokens, words, subwords, or punctuations even, that an LLM can process and remember at any given time. It includes the tokens from the user's prompt, which is the input, and the tokens the model has already generated, which is the output. If the conversation exceeds this limit, which can range from 8,000 tokens in the older models to over 128,000 tokens in newer ones like GPT-4 Turbo or Claude 3, the oldest tokens are dropped from the beginning of the sequence, meaning the model forgets the start of the conversation. The cost involved in these computations, mathematical operations, and the slowness in processing longer conversations are the primary reason driving this limitation. Having said that, you should know that some of the models such as GPT-4o, Claude Opus, and Gemini Flash support 1 million plus tokens. Quick check. Are you starting to see AI differently? If yes, hit the like button. If no, stick with me because the best part is coming. As the storyteller would pause, I would try to guess what came next. My only goal was to find out what happens next in the story before someone else said it. In other words, my only goal was to predict the next token. As my father paused, with the excitement of a kid that just got his first bicycle, I'd blurt out my guess, and then the ghost appears. But to my dismay, the neighborhood uncle, Ramji, hysterically laughs. Wrong, he says. That sharp sting of disappointment? I see now it was a loss function. Knowing that I made a mistake, a clear signal that my prediction was off. The feedback wasn't just wrong, it was nuanced. My father would say, no, a ghost wouldn't appear in a war story. It just breaks the pattern, which loosely translated in Hindi as भूत कहां से आ गया वॉर की स्टोरी में बुड़बक हो क्या. That specific pointer on how I was wrong was the gradient. And that feeling would travel backward through my thoughts, through the neurons that I was building all along in the neural network, forcing me to reevaluate. That was my back propagation. I'll go back to it and I'd weaken the link between ghost and a war story. And by doing that, I would be performing a gradient descent. That's just calculus. Constantly making tiny adjustments to my web of memories. In a similar way, backpropagation in the LLMs adjusts weights based on gradients to reduce future prediction errors. One day, when my father was traveling for business, as we all sat down under the street light, and some of the kids from the neighborhood asked me to tell a story in my father's style, no points for guessing. In that moment, I felt very proud of myself. The kids also asked me if I could add some more action to the story that my father usually wouldn't. And then they would tell me to just make sure that they had a great laughter at the end of the story. Looking back at this, I think the kids were just great at prompting me to ensure what they wanted. And this is what prompt engineering is all about. In fact, if you were to ask me, there's no engineering there. It's just plain English, or a guided one at that. or what prompt engineering experts would call a structured prompting, giving clear instructions, context, and desired outcomes. But my mother, she was different. If I told a story and made the ending too sad or dystopian, maybe even made something up, she'd gently ask, which ending feels more hopeful? Do you think you could tell the story in a way that is not just helpful but also harmless? You see, she was my reinforcement learning from human feedback, my human in the loop, guiding my choices based on feeling and conscience, not just correctness. And this is what Karpathy also talks about in his video about truthfulness, helpfulness, harmlessness being the three important tenets of RLHF during the fine-tuning stages of the LLM. So let me ask you a question. What was your training data when you were a kid? Did you have a human in the loop that made an impact? Drop a comment and tell me, because every story matters and I would love to hear. With time, my reasoning also became more complex. Instead of just blurting out a guess, I learned to think out loud. I'd say, okay, the king is angry because the queen is missing and she was last seen near the dragon's cave. So the king will probably send his knight to the cave. I was laying out my reasoning step by step before giving the final answer. This was my chain of thought. It made my predictions much more accurate. Then I got even better. I learned to explore multiple story paths in my head at once, like branches of a tree. Okay, I'd think path 1, the knight fights the dragon. Path 2, the knight seeks a magic sword first. Path 3, the dragon is the red herring and the queen ran away. I would evaluate these different branches and choose the most interesting one. This was my tree of thoughts, a way to brainstorm and prune possibilities before committing to a single story. Soon after, I became quite a storyteller myself, I would say. I could say now I had my own inference mode, but I wasn't perfect. In fact, far from it. Sometimes I'd mix up stories. Once, I was narrating the Battle of Panipat, and man, I was on a roll. The audience was captivated. And then I said it. The mythical dragon captured the soldiers and flew past the mountains. Can you believe that? What a blunder to make. Well, I would manage to get some laughter, or at best, some would call me a highly imaginative kid, but I was clearly hallucinating, creating plausible sounding stories that were factually wrong, because in my mind, the patterns had gotten jumbled. Somehow, in my mind, the mythical dragon from Ramji's stories sort of made sense in the story my father had told me about the Battle of Panipat. It was a powerful lesson. My brain wasn't a database of facts. It was simply a pattern matching machine. And so is every LLM. Every time an LLM gives you an answer that's not right, it's not lying. It's just doing what I did, predicting the next word based on patterns, not facts. But I was smart. I learned a new trick to combat this. When I was asked a question I wasn't sure about, like the specific date of a battle my father mentioned, I learned not to just guess from my flawed memory. Instead, I would pause the story and take my father's help to find out about a particular event in the War of 71, or my mom to find out more about the Baga tribe. When they were not around, I would excuse myself and run over to the bookshelf in the corner of my house, pull out the specific history book or an encyclopedia, and find the exact page with the date. I would read that fact, come back to my audience, and then weave it seamlessly into my story. You see, I was augmenting my storytelling by retrieving real-world information. This, I now realize, is exactly what retrieval augmented generation or RAG does. It gives the model an external library to consult, ensuring its stories are grounded in fact, not just memory. This is where the organizations use RAG to augment their LLM-generated responses with facts from the process documents or customer service SOPs, etc. Looking back at that 10-year-old boy, I often wonder who I would have become had I grown up in a different house, a different neighborhood even. If my training data had been different, if I had only heard my father's historical accounts and my neighbor's serious stories, I would have become a very different kind of storyteller, factual, precise, maybe a bit dry. If I'd only been surrounded by my brother's ghost stories and my mother's fantastic folklores, I would have been more creative, more whimsical, but perhaps less grounded in reality. The stories I was fed directly shaped the storyteller I became. This is why different LLMs or even different versions of the same LLM may have different characters. One trained on scientific paper has a different personality than the one trained in poetry. On that note, I just realized how I'm a sum total of the teachings of my mother that made me a kind, compassionate, and a humble person, and the life lessons from my wife that made me a fierce competitor, an ambitious person, and most importantly, a loving husband and a father. And isn't that true for all men? I guess it's fair to say we are all trained with different data sets grooming us into the men that we are today. You see, I never truly understood the deep sorrow of a war or the real terror of a ghost. I had no true understanding. I was just an incredibly sophisticated guesser, if that's a word. My brain had become a machine that had compressed the entire universe of my neighborhood stories into a set of predictive connections. I was merely an echo of the stories I was told. I wasn't learning to think, I was learning to predict. And sometimes a prediction is so accurate and beautiful, it feels like wisdom, it feels like magic, it feels like a story you were always meant to hear. So, what was really happening in my 10-year-old mind? When I think about it, it was nothing but a beautiful, chaotic symphony of simple math. My mind had different sections for different tasks. The part that saw patterns on the mosaic floor was my CNN, a master of space. But the part that lived for stories was my LLM, a master of sequence, all running on that special transformer architecture, or the listening room, if you remember. Each memory, each neuron was part of a larger group, a layer. When a new story came in, it was like a sound echoing through the forest of my memories. It would travel down every single pathway at once, its energy changed by the condition of each path. A strong, clear path would return a strong echo. An overgrown trail would return a faint one. The process of combining all these thousands of returning echoes into one new complex thought, that was matrix multiplication. It was the blending of a new idea with the entire landscape of my past. But not every new thought was useful. At the exit of each clearing in my mental forest stood a gatekeeper. This was my activation function. The gatekeeper's job was simple: listen to the newly formed thought. If it was a strong, clear, resonant idea, the gatekeeper would open the gate and let it pass on to the next clearing, its signal amplified. But if it was a weak, jumbled, nonsensical echo, just noise, the gatekeeper would close the gate, silencing it, preventing the noise from confusing the rest of the forest. It was a simple, ruthless process of deciding what was signal and what was noise. Like my mother, the LLMs found their way of telling right from wrong. My ability to focus wasn't just simple attention. It was like having multiple sets of ears listening to different things at once, a form of multi head attention. And my guesses weren't random, they were probability distribution, with some outcomes feeling more likely than others. My mood could change the outcome, making my guesses more creative or more predictable, just like adjusting a model's temperature and sampling. You could think of temperature as a creativity switch. A low temperature would make the model highly deterministic, meaning the LLM favors the most likely words, resulting in safe, factual, and repetitive text. A high temperature, on the other hand, will allow less likely words a better chance to be chosen, resulting in more random, creative, and diverse text. Under the hood, the LLM basically either scales up or scales down the probability of the next token or word being predicted. In contrast, sampling can be thought of as a word filter. It controls which words are even allowed to be considered for the next step. It limits the pool of words that the LLMs can choose from before the final selection is made. Together, you can use them to balance creativity and coherence, meaning the ability to be adventurous yet logical, consistent, and easy to understand. The process of learning, of getting better after each wrong guess, was a constant cycle. The gradient. The hint about how I was wrong allowed my brain to make those tiny adjustments. And the speed at which I was learning from my mistakes was my learning rate. In the end, my entire childhood of stories was compressed into this predictive machine. Think of this as Llama 270B's files for parameters and the runnable program, one file each. Specific character of that machine was a direct result of my unique family or neighborhood of storytellers. I wasn't recalling facts. I was simply generating sentences based on my training of what should come next. Ladies and gentlemen, my final take on generative AI. It's not a brain. It's certainly not a soul. If anything, it is the most beautiful tapestry of mathematics the human race has ever witnessed, trained on an infinitely gargantuan amount of data, and undoubtedly an innovation that has the power to change the course of how people learn, work, behave, and in many manners live their lives from here on. And that, my dear viewers, to me is nothing short of magic. We now come to the end of my story. But before we finish this video, I would like you to work out with the following thoughts. Number one, every time you talk to an LLM, ask it a question, ask it to generate an image or a video. Be conscious of what's happening under the hood. Think of the pre-training, the transformer architecture, the human in the loop. This not only helps you learn on the go, but it also helps you be aware of who you are talking to. A machine which is not intelligent, but trained. Number two, every time you ask it a question, remember, it is only making its best guess. And it's pretty damn good and reliable at that. But it does not really know you, nor does it know the answer to the question you're asking it. Use it with guardrails for your customers if you are a business. Use it with caution for help on personal matters if you're an individual. It's not a friend or your parents that are advising you. It's a machine, or even better, or worse. It's just maths and lots of data. And now you know why AI will never replace human beings. That is, at least in the context of being your true well-wishers and companions. So, if you have a medical problem, research it, but talk to your doctor. A legal problem, research it, but meet a lawyer. A career issue, research it, but consult your friends, seniors, or your elder brother. If it's a relationship issue, research it, but talk to your friends. More importantly, talk to the person in concern. If it's a life issue, research it, but talk to your parents. They've been there, done that. That was my take on how generative AI works through my own story of how I became a storyteller. I sincerely hope that it helps you in your journey of learning AI. Please do share this video with your friends, colleagues, and family members if you like it, because like you, they too deserve to experience it, need to understand it, and learn to use it. Thank you so much for watching. See you in the next video. Ta-da!